In the previous video, we looked at how to extract statistics from time series data and analyze the information regarding the nature of data. In this video, we're going to take a look at sequential data analysis by building hidden Markov models. The hidden Markov models, HMMs, are really powerful when it comes to sequential data analysis. They're used extensively in finance, speech analysis, weather forecasting, sequencing of words, and so on. We're often interested in uncovering hidden patterns that appear over time. Any source of data that produces a sequence of outputs could produce patterns. Note that HMMs are generative models, which means they can generate the data once they learn the underlying structure. HMMs cannot discriminate between classes in their base forms. This is in contrast to discriminative models, which can learn to discriminate between classes but cannot generate data. For example, let's say that we want to predict whether the weather will be sunny, chilly or rainy tomorrow. To do this, we look at all the parameters such as temperature, pressure and so on, whereas the underlying state is hidden. Here, the underlying state refers to the three available options: sunny, chilly or rainy. If you wish to learn more about HMMs, check out this tutorial on this website. Here we will use HMM Learn to build and train HMMs. Make sure you install this before you proceed. You can find the installation instructions at hmmlearn.readthedocs.io. Now let's go to the editor. We first create a new Python file, hmm.py. Then we import these necessary packages. We'll use the data from a file named data.hmm.txt that is already provided to us. The file contains comma-separated lines. Each line contains three values: a year, a month, and a floating point data. So, here you can see the year, the month, and this is the floating point data. So, let's go to our file, i.e. numpy.py. Now, let's load this into a numpy array. Let's stack the data column-wise for analysis. We don't need to technically column stack this because it's only one column. However, if you had more than one column to analyze, you can use this structure. Next, create and train the HMM using 4 components. The number of components is a hyperparameter that we have to choose. Here, by selecting 4, we say that the data is being generated using 4 underlying states. We'll see how the performance varies with this parameter soon. So, we've trained the HMM using these lines of code. Now let's run the predictor to get the hidden states. After this, compute the mean and variance of the hidden states. As we discussed earlier, HMMs are generative models, so let's generate, for example, 1000 samples and plot this. The full code is given in the hmm.py file that's already provided to us. Finally, let's see what output we get when we run this file. So you can see the figure for the number of components, that is 4. You can also see the mean and variance for different states. You can experiment with the n components parameter to see how the curve gets nicer as you increase it. So let's move back to our editor. You can basically give it more freedom to train and customize by allowing a large number of hidden states. So let's change it and increase to 8, and check the output. Here is the output, got number of components equal to 8. Let's now try the same by increasing it to 12. You can now observe that it gets even smoother from this output. Great. In this video we've built a hidden Markov model for sequential data analysis and uncovered hidden patterns. In the next video, we'll see how to build conditional random fields for sequential data.